Hey guys, I want to speak real quick on some of the motion stuff we've been learning about in class last week and this week. And last week we learned about distance and displacement, and then speed and velocity. I want to cover those real quick and then show you a couple motion graph things real quick, which we talked about in class today. So with distance is the total amount traveled. So pretend these are 4 location points. If we're starting up here, if you travel from here to here, down to here, your total distance would just be 5 plus 4, which should be 9. Okay. Your displacement then is how far your ending point is away from where you started. So let's say I traveled from here to here and then went down, and then I traveled over to this spot. My distance would be 5 plus 4 plus 5, so that'd be 14. But my displacement would be the difference between where I finished compared to where I started. Displacement doesn't take into consideration the journey. It just looks at where you finished compared to where you began. So in this case, my displacement would just be 4. Okay. Along those same lines, let me prop you up real quick. Speed is how fast something's moving, and then velocity includes it's your speed in a certain direction. So again, real quick. So speed is going to be the distance divided by the time, and then velocity is equal to the displacement divided by the time. Okay, and the other way to show this is a change in the x. Okay, and then you just pretty much plug those values into your calculator, and that'll tell you what your speed and your velocity are. Do remember that your velocity and your displacement both need direction. So your displacement, if it moves to the right, your displacement is going to be a positive number. If it moves to the left, think about like a number line. If you end up to the left of where you started, your value is going to be a negative. Or if you know certain directions, let's say I ended up 10 meters north of where I began, that'd be displacement. And then your velocity also includes a direction as well. So, and then today we looked at distance and time graphs. So the time would go along the bottom, and then the distance goes on the y-axis. Because this is your independent variable. As the time increases, the distance is going to be the responding variable towards that. Okay, so if you see a line that is just a nice regular diagonal line, this would be moving at a steady pace. Okay, and then, whoops, that's not good. If you see a line that is more shallow, if it's a flatter line, it means that, okay, so as the time's continuing, its distance isn't increasing very much. So if you see a line that looks like this is going to be a slow, steady pace. And then if you see a line that is really steep, this would be a fast motion because its distance is increasing in a shorter amount of time. Okay? And then if you see 2 more things, if you see a line that starts, let's say it's going at a steady pace, and then it goes flat. A flat line indicates that there was no motion, so the distance isn't changing during this time period. So if the distance isn't changing, that means that it's stopped, it's at rest. Okay, and then the last little bit, if you ever see a line that dips to the left, if it drops down, so let's say it's going to go up fast, and then it stops moving, and then it drops down. This part right here indicates that it's going backwards, or going to the left. In that motion man activity, if you were able to access that, you'll see that. So anytime you drag the guy to the right, you're going to have a line that's going up. regardless of how fast you're moving. It's going to go up. And then if you stop it, it's going to be flat. And then if you move your guy to the left, your line on your activity, the line's going to drop down. All right, and we'll continue practicing with these over the next day or two. We're going to do an activity called Hot Wheel in Physics. Let me show you one more, sorry. If you see a line that starts out slow and then it curves upward, a curved line means that something is accelerating because it started out slow. Now it's a steep line, so that means it's moving really fast. So if it's a curved line like this, that means that they're accelerating, going faster. All right, let me know if you have any questions.